Multiplying and dividing rational expressions. Multiplying rational expressions. If a divided by b and c divided by d are rational expressions and b and d are non-zero, then a divided by b times c divided by d equals ac divided by bd. In words, to multiply two rational expressions, write the numerators as a product and write the denominators as a product. How to multiply rational expressions. To multiply two rational expressions, first, factor the numerators and the denominators. Second, multiply by using the property a divided by b times c divided by d equals ac divided by bd, where b and d are non-zero. Third, simplify the result. In this example, find the product 5m minus 20 divided by 21m to the sixth times 7m squared divided by 3m squared minus 12m. We cannot just start canceling things because of the 5m minus 20 and the 3m squared minus 12m. For those, we are going to have to find a greatest common factor. 5m minus 20 have a common factor of 5, which leaves us with m minus 4 in parentheses divided by, rewrite 21m to the sixth, and that's multiplied by, rewrite my 7m squared, divided by 3m squared minus 12m has a greatest common factor of 3m, and that leaves me with m minus 4. Now we can cancel because I have 5 times my m minus 4 and 3m times m minus 4. The m minus 4's cancel. I could cancel my 3 with my 7 or 5, but they don't have anything in common. I can cancel the 21 and the 7, however. 7 goes into 7 one time. 7 goes into 21 3 times. M cancels with m squared, leaving me with m to the first. M to the sixth can cancel with that m to the first, leaving me with m to the fifth. So you can go straight to the answer from here, but technically what I have is 5 times 1 because my m minus 4 canceled, times 1 because of the 7, times 1 because of the m's, divided by 3 because 21 divided by 7 is 3, times m to the fifth because I was able to cancel out 1m, times 3 times 1 because I canceled an m, times 1 because I canceled my m minus 4. So our final answer is 5 divided by 9m to the fifth. The m to the fifth must be in the denominator. In this example, find the product of 2x squared minus 12x divided by 25 minus x squared times 3x minus 15 divided by x squared minus 2x minus 24. The 2x squared minus 12x, 3x minus 15, and x squared minus 2x minus 24, looking at the term with the largest exponent for these three polynomials, they all have a positive coefficient. The only one that doesn't is 25 minus x squared. I can factor that by first rewriting this as negative x squared plus 25. I want that x squared to be positive, so I factor out a negative 1, leaving me with x squared minus 25. Then I can factor my x squared minus 25. So I have my negative x minus 5, x plus 5. So factoring the rest of my problem, for 2x squared minus 12x, I can factor out a 2x, which leaves me with x minus 6. In the denominator, we have our negative x minus 5, x plus 5, times, in my numerator, I can factor out a 3 times x minus 5. My denominator, x squared minus 2x minus 24. I need two numbers that multiply to be a negative 24, but add to be a negative 2. X minus 6 times x plus 4. Now I can cancel everything that's in common. X minus 5 cancels with x minus 5. X minus 6 cancels with x minus 6. One of the ways I can write my answer is by writing this negative in front of the entire answer. So equals negative 2x times 3 is 6x divided by x plus 5, x plus 4. I can also write it in front of the 6x if I wanted, or in front of my denominator. In this example, find the product m squared minus 6mn plus 9n squared divided by m squared plus 3mn minus 10n squared times m squared plus 10mn plus 25n squared divided by m squared minus 4mn plus 3n squared. M squared minus 6mn plus 9n squared. I need two numbers that multiply to be 9 but add to be a negative 6. M minus 3n times m minus 3n. And if you write it as m minus 3n parentheses squared, it's the same thing. M squared plus 3mn minus 10n squared. So I need two numbers that multiply to be a negative 10 but add to be 3. M plus 5n times m minus 2n. And this is times m squared plus 10mn plus 25n squared. Two numbers that multiply to be 25 but add to be 10. M plus 5n times m plus 5n, which is the same as m plus 5n parentheses squared. M squared minus 4mn plus 3n squared. I need two numbers that multiply to be a positive 3 but add to be a negative 4. M minus 3n times m minus n. Now we can check to see if anything cancels. M minus 3n cancels. M plus 5n cancels. So I can write my answer as m minus 3n times m plus 5n divided by m minus 2n times m minus n. Dividing rational expressions. If a divided by b and c divided by d are rational expressions and b, c, and d are non-zero, then a over b divided by c over d equals a over b times d over c. In words, to divide by a rational expression, multiply by its reciprocal. How to divide rational expressions. To divide two rational expressions, first, write the quotient as a product using the property a over b divided by c over d equals a over b divided by d over c, where b, c, and d are non-zero. 2. Find the product. 3. Simplify. In this example, find the quotient. 3b squared minus 27 divided by b squared minus 12b plus 35 divided by b plus 3 over b squared minus b minus 20. So our first step is to get rid of the division symbol. If you're comfortable changing this to multiplication and factoring at the same time, you can do it in one step. 3b squared minus 27, I can factor out of 3, which gives me b squared minus 9, divided by, I'm going to bring over my b squared minus 12b plus 35, and that's times b squared minus b minus 20 divided by b plus 3. I'm going to continue factoring, bring down my 3. B squared minus 9 is b minus 3 times b plus 3 divided by b squared minus 12b plus 35. I need two factors that multiply to be 35 but add to be negative 12. b minus 7 and b minus 5 times b squared minus b minus 20. I need two factors that multiply to be a negative 20 but add to be negative 1. b minus 5 and b plus 4. And that's divided by b plus 3. I can cancel out a b plus 3, a b minus 5. So my final answer is 3 times b minus 3 times b plus 4 divided by b minus 7. In this example, find the quotient w squared minus 2w minus 8 divided by 12w to the fourth plus 32w to the third minus 12w squared divided by w squared minus 9w plus 20 over 12w to the third plus 42w squared plus 18w. Both of our current denominators have greatest common factors. So I'm going to factor out the greatest common factor and change the problem to multiplication in the same step. So bringing down w squared minus 2w minus 8, that's going to be divided by 12, 32, and 12 have a common factor of 4. W to the fourth, w to the third, and w squared have a common factor of w squared. So that leaves me with 3w squared plus 8w minus 3. So that's times my 12w to the third plus 42w squared minus 18w is going to move to the top. 12, 42, and 18 have a common factor of 6. W to the third, w squared, and w have a common factor of w. That leaves me with 2w squared plus 7w plus 3. And then I have w squared minus 9w plus 20 on bottom. Now we're ready to factor into two parentheses. W squared minus 2w minus 8. I need two numbers that multiply to be a negative 8 but add to be a negative 2. So that's going to give me w minus 4 times w plus 2. Divided by, I'm going to bring down the 4w squared. I need two numbers that multiply to be a negative 9 because 3 times negative 3 is negative 9, but add to be 8. So if I use a positive 9 and a negative 1, 9 times negative 1 is a negative 9, 9 plus a negative 1 is a positive 8, and 9 over 3 reduces to 3 over 1. Factors 3w minus 1 times w plus 3. And that's going to be times, I bring down the 6w. Now I need to factor 2w squared plus 7w plus 3. 2 times 3 is 6. I need two numbers that multiply to be 6 but add to be 7. So if I use 6 and 1, 6 times 1 is 6, 6 plus 1 is 7, and 6 over 2 reduces to 3 over 1. So I have the factors 2w plus 1 times w plus 3. For w squared minus 9w plus 20, I need two numbers that multiply to be 20 but add to be a negative 9. So w minus 4 and w minus 5. Now I'm ready to cancel. So I can cancel w minus 4. I can cancel a w plus 3. 4 and 6 have a common factor of 2. 2 goes into 6 3 times. 2 goes into 4 2 times. And the w cancels with the w squared, leaving a w. So my answer is 3 parentheses w plus 2 and another parentheses 2w plus 1 divided by 2w times 3w minus 1 times w minus 5. I can't cancel anything else. In order to cancel any more of the w's, I'd have to have my parentheses identical. I can cancel out the greatest common factors only if there's something in common, and 3 and 2w don't have anything in common. Multiplying and dividing rational expressions. To multiply two rational expressions, 1. Factor the numerators and the denominators. 2. Multiply by using the property a divided by b times c divided by d equals a times c divided by b times d, where b and d are non-zero. 3. Simplify the result. How to divide rational expressions. To divide two rational expressions, 1. Write the quotient as a product using the property a over b divided by c over d equals a over b times d over c, where b, c, and d are non-zero. 2. Find the product. 3. Simplify.